Hello and welcome. So we'll be solving another interesting question on point of contraflexure. This question is going to help us to know that it is not all question that require you to calculate point of contraflexure that actually has point of contraflexure. Exactly, because there's a moment in exam you can be tense and you can be given a question like this, and by the time you finish drawing your shear force diagram, your bending moment diagram, and there's no point of contraflexure, you might think you are wrong. You are not wrong. Exactly, you might not be wrong. Exactly, it's not all question on bending moment and shear force that has point of contraflexure. All right, so we'll be starting with the summation of the upward forces equals to 0, and upward force positive and downward force negative. All right, so the upward force that we have here is our arrow A plus our arrow B, all right, which will be equals to 1000 plus 1000. All right, so our arrow A plus our arrow B will be equals to 2000. So this will be our equation 1, or we can make our arrow A the subject. So arrow A will be equals to 2000 minus arrow B. So let's call this equation number 1. All right, I hope we understand. All right, so now the next thing we are going to do is we are going to take our moment, the summation of moment about point C. So the sum of moments about point C should be equals to 0. All right, if we take our upward force to be positive, it means the moment produced by our upward force will also be positive. Our downward force negative, the moment produced by our downward force will also be what? Negative. All right, so let's start with this point here. We have 1000 multiplied by the total distance. It is a downward force. Okay, let's start with RA. RA is an upward force, so the moment produced by this upward force will be positive. RA multiplied by 2, so it's going to be reaction at A multiplied by 2 plus reaction at B multiplied by 8 plus 2, that is 10. So multiply by 10, which will be equals to our downward force now. 1000 multiplied by total distance, 1000 multiplied by 12 plus 1000 multiplied by 12. Okay, that's everything that we have there. That's everything that we have there. All right, so 1000, this is going to give us 2 arrow A plus 10 arrow B, which will be equals to what? 12,000. All right, so if we substitute for our arrow A here, we're going to have 2 into 2000 minus arrow B plus 10 arrow B will be equals to 12,000. All right, so if you clear the bracket now, we're going to have 4,000 minus 2 arrow B plus 10 arrow B, which will be equals to 12,000. All right, so this plus this is going to give us what? It's going to give us 8. So if we move this to this other side, and 12,000 minus 4,000, that is 8,000. So we are going to have 8 arrow B will be equals to 8,000. All right, so if we divide both sides by 8, then our reaction at B will be equals to 8,000 divided by 8 is going to give us 1,000 Newton. All right, so and our arrow A is going to be 2,000 minus arrow B, that is 2,000 minus 1,000. So our arrow A is also what? It's also 1,000 Newton. All right, so now the next thing we are going to do is to do our shear force calculation. All right, so shear force All right, so let's start with the shear force at point D. Shear force at point D will be equals to, so if you look at point D to our right hand side, we only have one force there, and it's a downward force. It's going to be minus 1000 Newton. All right, so at point B now, the shear force at point B will be equals to, so the shear force at point B, we have a downward force here and we have an upward force here. So it's going to be minus 1000 plus ROB, and our ROB is also what? 1000. So this is going to give us what? 0. So that is going to be our shear force at B. All right. So the next one is our shear force at A. So our shear force at A, to stand at A to our right hand side, we have these three force. So when we take the summation of this is 0, and if we add it to this, it's an upward force. So it's going to be shear force at A will be minus 1000 plus 1000 plus 1000, because ROA2 is also 1000. Then our answer is going to be 1000 Newton. All right. So the shear force at point C, point C. All right. So our shear force at point C, if you stand at point C, you add all these forces together. If you add this, it's going to be 0. Add this, is going to be 1000. So by the time we do 4, so we are going to have one minus 1000 plus 1000, then plus 1000 again, then minus 1000. So this will give us 0 Newton. All right. So the next one is the bending moment calculation. All right. So we'll start with the bending moment at point D. All right. So at point D, we only have a downward force to our right hand side. We don't have any distance. So this is going to be what? 0. All right. So the bending moment at point B will be equals to, we have a downward force, then the total distance is 2. So it's going to be minus 1000 multiplied by 2, which is going to be minus 2000 Newton meter. All right. So the bending moment at A is going to be minus 1000 multiplied by 10, the total distance, minus 1000 multiplied by 10, then plus our ROB multiplied by 8. Our ROB is 1000. So 1000 multiplied by 8. So by the time you do the math, you are going to have this to be what? Minus 2000. So this is going to be minus 2000 Newton meter. Just trying to manage my space. Let's see. Minus 2000 Newton meter. All right. So the bending moment at C. All right, the bending moment at C. If you stand at C, you are going to have minus 1000 multiplied by the total distance. So minus 1000 multiplied by the total distance is 12, plus ROB multiplied by 10. Our ROB is 1000 multiplied by 10, then plus ROA plus 1000 multiplied by 2. So if you do your math, you are going to get 0. So that is what you are going to have. So the next thing is just to draw our diagram. All right. So the two lines here, they are the reference line. The first one is the reference line for our shear force. Second one is the reference line for our bending moment. And above both line is positive, below both line is negative. All right. So let's start with the shear force diagram. All right, for the shear force at point D, this is point D, there's nothing but what? Negative 1000. So let's take this as our negative 1000. Let's take this as our negative 1000. So between D and B, we don't have any force. So it's going to be a constant line. All right. So our shear force at point D is 0. So this is 0 here. So I'm going to join from this point 0 to. All right. So between B and A, we don't have any force. It's just a constant line, which is already there. So we'll leave it. And the shear force at point A is positive 1000 again. So let's take this to be a 1000. All right. And A and C, we don't have any force. It's going to be a constant line as well. All right. So, and the shear force at point C is 0. So we are coming back to 0. All right. So all right, so that's it. So this is positive, this is negative. So you can shade. All right, that's it. So our bending moment at point D is 0. And our bending moment at point B is negative 2000. Negative 2000. All right. So let's take this as negative 2000. All right. So anywhere we have a straight line in our shear force diagram, will be representing with our what? Inclined line in our bending moment diagram. All right. So that's it. All right. So and between B and A, we don't have any force. So it's going to be a constant line here. Oh. Sorry. The bending moment at point A is 2000. So, and don't forget this one too is 2000. So this one is also going to be 2000. All right. So now we cannot draw a constant line now. All right. All right. All right. And a point C is 0. All right. So you can see we don't have any point of contraflexure. So here is the solution to the above question. Thank you.